right, so let's jump into it. Can anyone tell me what like terms are? So when I say like terms, what do I mean? And at this point, you can raise your hands if you want to. So anyone who would like to raise their hand to tell me what a like term is? Listen.
Ma'am, like terms are number with same value.
Excellent. Okay, so guys, like terms are terms in an expression that have the same variable and exponent. So let me just get that all down. Terms in an expression. Now, we haven't done exponents yet. We are going to do them, but I'm going to put it in the definition for now so that when we do exponents, we're reminded of it. Now, guys, remember we spoke about what variables are in our first lesson on algebra. Variables are the letters, and so they must have the same letters and exponents. So we're going to start to identify some like terms as we go along, but an example of this would be something like 2x squared and negative x squared. What we can see is that they've got the same variable x and the same exponent of 2. And because they have the same variable and the same exponent, we have what we call like terms here. Now, another important thing that we need to remember is that terms are always separated by plus and minus signs, not by multiplication and division signs. Okay, and that's really important to remember as we start to look at our expressions. We need to know where our terms are. Okay, Lexa, I see you raising your hand quite a bit. If you've got a question, please do put it on the chat. Otherwise, wait until we have question time. But do feel free, guys, remember to put your questions on the chat. Yolanda or I will help you, or you can send a message to Yolanda or myself. We will help you. Okay.
Yeah, definitely. I instructed Lexa to raise her hand, but based on you saying they should raise their hand, and then she didn't get up.
Oh no, sorry. I saw the hand go up and then it went down. So if you want to raise your hand, you can raise your hand. That's fine. Let's sort it out. Sorry, it went up and then it went down. So I was just a bit confused about what was happening. But you can raise it, Lexa, if you want to, and then we can deal with whatever the problem is. Beatrice, you need to tell me exactly what you don't understand so we can help you.
Yeah. Let's go, my people. Jesam is giving us a chance to ask what is it that we don't understand. Okay.
Okay,
so
guys, I'm just gonna I'm gonna pause for like 10 seconds. Take your screenshots here. And then if you have questions, put your hands up or put them in the chats. Let's deal with it now before we carry on. So any questions that you have, you can raise your hand or unmute or whatever it is that we're doing. Oh, excuse me.
Let's go, Beatrice. I want to see your hand up. Beatrice, find the reaction button. There we go.
Yeah.
Yes, you can unmute and talk.
What's up?
You have to unmute yourself. There we go.
There we go.
Miss, I still don't understand where the set terms are separated by plus or minus signs. I still don't get that part.
Okay, so basically, and we're going to have a look at some examples now, but basically if I give you an expression like 2x squared plus 3x minus 5, for example, these plus and minus signs are the things separating my term. So that separates my term and that separates my term. So what that actually means is that I've got one term of 2x squared, a second term of 3x, and a third term then of negative 5. So the plus and minus signs are separating my terms into like one thing that we deal with at a time.
Okay.
Okay. And guys, terms are important because as we start to simplify, we need to know whether or not we're adding or subtracting the terms. And we need to know whether or not they're like terms.
Okay.
Okay, Tandawake, again, like if you raise your hand and give me a specific question, I can try help. Otherwise, like Yolanda says, we're going to do some examples and hopefully it'll start to make sense. Right, so guys, I'm just going to wait in case anyone wants to screenshot with the example of terms there. Otherwise, we're going to move on and have a look at some examples now. All right, so what we want to do here in our first examples, we want to simplify the following expressions. Now we're going to go through this quite slowly because we need to make sure that we understand these things as we go along. So the very first thing that I always want to do when I'm looking at an expression is I want to identify my terms. Now to do that, as we've just said, we need to identify where our plus and minus signs are. So here I've got a minus sign, which means that I have got two terms. I've got one term of y and a second term of minus y. The next thing I want to do is I want to simplify my terms. Now this doesn't always happen, right? So you'll see here in this first question, these terms of y and negative y are already simplified. I'm not needing to distribute anything. I'm not needing to divide anything. That's done. So this step doesn't always apply, but it sometimes does. And it is going to become important as we start to move up in our algebra. But what we want to focus on right now is we want to add and subtract our like terms. Now we've spoken about what like terms are. They are terms with the same variable and the same exponent. And so what we can see here is that y and negative y are like terms. It's the same variable with the same exponent of 1. Now guys, what you also need to remember is that in front of any variable, there is a coefficient of 1. So if there is not a number written in front of your letter, there is actually a 1 there. It's a ghost 1. We don't have to write it in, but it is there. And this is important because now when I start to add and subtract, what I'm actually doing is I'm adding and subtracting the coefficients. So if we just take a little sort of tangent here, and if I had given you 3 minus 3, so if I took the same thing away from itself, you would all tell me that that is 0. If I told you 5 minus 5, you would tell me it's 0. I'm taking everything away. I'm left with nothing. And the same concept applies here. If I've got y and I'm taking away y, I'm taking away the same amount. And so what's going to happen here is I'm actually left with 0. So be mindful of that when you start adding and subtracting terms, that sometimes our like terms subtract or add to give us 0. Right, but if we have a look at question B, again, we're going to follow these 3 steps, but here we're actually going to get a nice answer. So if we have a look, we want to identify our terms. So here are my minus signs. So I've got 1 term, 2 terms, 3 terms. I want to simplify each term. In this case, that's already done for me. I'm not multiplying anything. I'm not dividing anything. They are what they are. And so now we want to check if we have like terms. Well, if we have a look at this, all of these terms here have a variable x and an exponent 1. So these are all actually like terms. Now, like I say, what we're doing is we're actually just working with the coefficients. So if I have 6 x's and I take away 2 x's, that's leaving me with 4 x's. And now I'm taking away another 1x, leaving me with 3 x's. And so my simplified answer here is 3x. So again, I started with 6 x's. I took away 2. I took away another 1. And so I'm left with 3 x's. And that's essentially what we do with our like terms. We take the numbers in front of them and we add or subtract them. We don't change anything to do with the variable. The variable stays exactly as it is. It's the numbers in front that we change. Right, so what I want is you guys to try number C. You can put your answers in the chat. I did see one or two hands. So while everyone's trying, if you have questions, you can raise your hand for me. Otherwise, you're trying question C. Beatrice?
Ma'am, I wanted to also basically, do you just add the numbers? So 6 minus 2 minus 1, do you just add, subtract or add them, and then you put an X in front of them?
Exactly.
In front of your answer.
Exactly. So whatever the letter is, that's what we put after we've added or subtracted the numbers.
Okay.
Perfect. Well done.
Thank you, ma'am.
Okay, so guys, that's a very nice summary of what we're doing. We're basically adding or subtracting the numbers in front, the coefficients, and then we just add the variable. Because like I say, the variable doesn't change. It stays X, it stays W, it stays Y. It doesn't change anywhere. So actually what we're doing is we're working with the numbers in front, or the coefficients. Obile, tell me what you don't understand and I'll try help, or raise your hand and ask me a specific question and I can try help. Right, but guys, I'm seeing lots of really great answers. Remember, the coefficients here to these W's are 1. So exactly as Beatrice has said now, we've got 4 W's, we're adding another W and another W. That leaves me with the total of 6 W's. And so exactly as a lot of you have said there on the chat, our simplified expression here is 6W. Someone was unmuted. Were you trying to ask me a question? Obile, I haven't seen your answer. Your hand come up yet? Are you sorted? Do you have a question?
Yeah, y'all can raise your hand and ask, because now is the time where you need to raise your hand. Beatrice, thank you so much for confirming that. That's beautiful. We always love to know. Yeah, Lixa's hand is up. Unmute Lixa, you have the power.
Could I please ask that? I want to ask about the quizzes. If you fail the quiz, could you redo it?
Lixa, definitely you can redo it as many as you would like. But remember that with the people that we show during the beginning of the lesson, it's only those ones that tried once and they got 100%. But yes, you can.
Okay.
Alrighty, guys, I'm glad this is all making sense. Can I just get a thumbs up or thumbs down in the chat if we're happy or we're not so happy with these first 3 examples? Because like I say, this is so important. We need to make sure we're okay with what's going on here. So just give me a thumbs up or thumbs down in the chat. Good. Nice, grade 8. It's all done. Seeing all the thumbs up. Good. And guys, remember, don't feel embarrassed if it's a thumbs down. That's absolutely fine. We're not all necessarily feeling as comfortable with algebra. That's okay. But then do remember to ask your questions as you go along. Nice, grade 8. Well done. Okay, so let's have a look at another simplification. So because you guys all thumbs up, what I want is for you to try these 3 by yourself. So you're going to put your answers in the chat A, B, and C. So make sure you label them. And then once we've given everyone a minute or 2, I will ask for some hands to give me answers. But I want you to try these by yourselves. Remember, to identify your terms, identify your like terms, and exactly as everyone's now doing on the chat, please label your answers as you put them into the chat for us so that we can see what it is that you're doing. And I've just realized that this is exactly the same question as what we had earlier. Because clearly I'm losing my mind. So let's do C as 4W minus 2W plus 3W. Okay, so I've just changed C there because apparently I put the same question twice. I'm losing my mind. Keep those answers coming. Well done. Well done, grade 8. Keep those answers coming, Eugene, really nicely. Alrighty, does anyone want to raise their hand to give me some answers here? Okay, Muvuyo, tell me what A is.
A, it's y plus 1 equals to 2y because of the ones which are visible.
Perfect, well done. So guys, exactly, we've got those invisible ones in front of the y. So I've got one y, I'm adding another y, so I end up with 2y. Excellent, well done. Olonda, do you want to help me with B?
Yes, ma'am. So B is 2x plus 3x plus x equals 6x because
Okay, you cut out, yeah?
2x plus 3x plus 1x equals 6x.
Excellent. So guys, again, remember there's that invisible or that ghost one in front of the x, as Alonda said to us. And so we need to remember it's there. And exactly as Alonda said, we simplify that to 6x. Very nice. Well done. All right. Mohau, would you like to help me with, what are we on? C. It should be, there we go.
Yes, I think the answer for C, it's 4, like when you're doing it, it's 4W minus 2W plus 3W equals to
Mohau, sorry, I didn't hear your answer. What is it equal to?
it's equal to 5.
5.
Good, well done. Good, well done. 5W. Now, guys, remember, and this is going back to what Beatrice said earlier, this is essentially just us adding or subtracting the numbers or the coefficient. So if you need to, again, go back to that number line that we spoke about when we did integers. So something like question C that has both addition and subtraction, use your number line. So we're starting at 4Ws, we're taking away 2, but then we're adding on 3Ws. So of course I didn't draw my number line big enough. And so we end up at positive 5Ws. So there's always a way to get to our answer if we're feeling a little bit uncomfortable, whether it's a number line, a calculator, writing out it in groups, whatever the case is, find a method that works for you. Alrighty, Chiro, I did see you had a question. You're welcome to raise your hand for any questions. Those of you that want to take screenshots, I'm just going to do this so you can screenshot the first and second set of examples. Chiro?
Hi, ma'am.
Hi.
I was asking if it does it happen that sometimes you don't get like the same variables. I don't know if I'm making sense.
Yes, so sometimes it does happen that we don't have, and we are going to look at some examples like that. But yes, definitely.
Thank
Good
you.
question. Kobile? You there?
Hello.
Hi, do you have a question?
No, ma'am.
Oh, okay, your hand was raised.
Yes, ma'am. It was
Okay.
We don't raise our hand if we don't have a question, okay, my people? Komoto, do you have a question? You can unmute and ask.
Hello, ma'am.
Hi.
So, ma'am, I was asking if there's a letter, for example, an X, should we always put a 1? Is it compulsory to put a 1?
So no, it's not compulsory. The reason I sometimes put the 1 there is just to help me remember that I do have an X there. But if you're comfortable not needing the 1 there, that's okay.
Oh, okay. Thank you, ma'am.
Pleasure. So guys, just again, you don't have to put the 1 in front of the x's. So like here, I put a 1 in front of the x and I put 1s in front of the y's. If you don't need that and you know that there's a 1 there without needing to fill it in, that's fine. I just do it to remind myself that I do actually have a 1x there. Righty. Okay, let's take a brain break before we have a look at this. And this is going to be now, okay, no, I've distracted myself with my own thought process, so just ignore me. Brain break. Hopefully we remember these. We've got our little trucks, trains, and diggers that we're going to find the values of. I just wanted you to see my math joke because I really enjoyed this one. Thought it was hilarious. It says, student 1, I saw my math teacher with a piece of graph paper yesterday. And then the other student said, she must be plotting something.
Yeah.
I know
That
they're
is the best
super
joke
corny.
ever. Oh, y'all will get it when we do graphs, then you understand. For now, maybe you're a little bit like, I don't get it. But you'll definitely understand when we do graphs.
All right, guys, so there's your brain break. I'm just making it a bit bigger so that you can see where you've got 2 of each. So just so we're all clear. For example, there's 2 diggers, there's 2 trains, etc., etc. We need to be careful when there's 2 of them. So we are wanting to work out the values of our trucks, our trains, and our diggers in order to work out the final value over here. So while you're doing that, well, unless you've got like a question that is troubling you, or do you want to give me answers?
It's an answer for the question.
Okay, so what we are gonna do, guys, is we're gonna wait until we've got a final answer from someone, and then that person will tell us how they got to their answer. So put your answers in the chat and we'll have a look and see until we get a final answer.
How, if you have an answer, put it on the chat. We'll definitely let you know if you got it correct or not. Okay, and guys, remember, I can take your power away, so don't overuse it. So make sure that you are always muted all the time, unless if you're talking to Teacher Sam and I, okay? So mute yourself, please. Otherwise, I'll have to take that power away. Okay, so Mohau, if you got an answer, put it on the chat. What's your final answer? And then we'll definitely let you know if you got it correct or not. We need the final answer. Where there's a question mark supposed to have an answer, what is it? This is what we are saying. And the first person to get it correct, of course, we're gonna celebrate with you, and you're definitely going to tell the class that you got it correct. And how did you get it correct? I'm cheating. I'm still waiting for Teacher Sam to tell me what's the answer. Okay, so far, Mivuyo, keep trying. That's not it. Kovile, that's not it. No, it's not it. It's not 100 at all. Keep trying.
So Andile has helped us out for the first one. So if you're struggling, have a look in the chat. Andile helped you out for the very first equation there.
Lixa is not 215. Fiona is not 56. Let's go, my people. Y'all have 2 minutes left to figure it out. It's not 144. It's not 300. It's not 104. It's not 190. Remember, take it slow, guys. Take it step by step. If you do it step by step, like the way that Teacher Sam has taught us, because this brain break is related to what you have learned. So look at the chapters and then try and decide what letter do you want to call them. And then you can start doing some maths. None of those answers, they are correct so far. I haven't seen any correct answer. What I can tell you is that on line number 2, that funny shongololo or funny train there, or goose, I don't know what it is. It's only 1. And then on the third lane, both of those ones are 2 2s. They're like in pairs. And also on the final one, they're like in pairs. Okay, that's the only thing that I can say, because if you don't see the picture correctly, I have given you a hint. So far, no answer.
Oh, great.
You're allowed to say that we give up, ma'am. You're allowed to say you give up, and then it will be for homework.
I think.
Okay, so yeah.
I think I'm gonna go through this one just because this is the second one we've struggled with, and so I'm gonna go through it so that you can see how to do it, and then hopefully next week, because you've listened to me now, you will be able to do it.
But says that I give up, man.
Okay, so guys, like I say, ideally helps us was the first one, and Yolanda said you can use variables if you want. So what we actually have here are the same things being added. So we've got x plus x plus x, which is 3x, is equal to 24. So if we think back to our equations and solving equations, we know that to solve this, we would divide both sides by 3. And so we know that each of these trucks here is 8. And so now every time I see a single truck by itself, I know it has a value of 8. And so what that means is that, in the next step, I'm able to work out what my train is. So let's just be careful here. I know that 8 times something plus 8 must give me 80. So again, use inverse operations. If I take 8 off of that, I've got an answer of 72. So I know that when I times 8 by something, I must get 72. And so that means our train here is 9, because 8 times 9 is 72, and then plus 8 gives me 80. So now every time I see a single train, I've got 9. But what I need to be careful of, and this is what Yolanda was saying to you, like now when you were trying to figure this out, is that in this next step, it's a double train times a double train. So double 9 is 18. So what we actually have here is 18 times 18. Now again, we need to apply BODMAS. 18 times 18 is 324, if I'm not mistaken. Let me just double check my maths. 324. And so now that means that if we know that the product is 324 and we must get to 338, we can go and work out what, actually we don't need to work out anything. Oh, we do, we've got tractors, sorry. We can work out what our double tractors are. Right, Mavuyo, well done. So our double tractors here are going to be 14, because if I say 124 plus 14, I get 138. And so now I know that in my final step, my double tractors are worth 14 and my double trains are worth 18. Now, again, we have to apply BODMAS. So we're going to do the multiplication first, which is 8 times 14, which gives us something, 112. And then we add our 18. And so as Mavuyo and a couple of other people have said on the chat, our final answer here is 130. So guys, this is how we do these brain breaks. We need to work out the value of each of our pictures, whatever they may be, in order to figure out our final answer. And once you've worked out one row, it's going to help you with the next row and so on.
I just want to mention that Mavuyo got it first before we even tried to explain. Before we were even halfway, Mavuyo have already got it an answer. So well done, Mavuyo. And some couple of you I saw, but Mavuyo was the first one to get it correct. And Fiona also got it correct.
Well done, guys.
Lixa has a question.
Yes. Lixa?
Could I please ask that will it be important if I screenshotted all of this?
You don't have to screenshot this. This is just something fun that we do. You're welcome to screenshot it, but it's not part of the content of the lesson.
Okay, thank you.
Alrighty, guys. So let's get back to some algebra. I'm hoping this makes sense now, and I'm hoping that means that from next week, when I give you something like this again, we know how to do it. Alrighty, but let's have a look at our examples here. And this is now, I think it was Chiro who asked, what happens when we have different variables, or what even happens when we don't have different variables? Okay, so what we need to remember is that our definition for like terms says they have the same variable and the same exponent. Now, when I'm working with algebraic expressions, I always like to have like a colored pen or some highlighters so that I can highlight my like terms. And as Mavoyo said there, what we want to do by highlighting or underlining or whatever is we're grouping our like terms so that we know exactly what we should be adding and subtracting. So here we can see that we've got two terms with a y in it. So those two terms would be like terms. But this 3 over here, that 3 is not a like term because it does not have a y attached to it. So this is now a completely separate group of terms that we need to consider. Now, just as a little side note, this value here of 3, if there is a number with no variable, so a number just by itself, this is what we call a constant. It is a value with no variable. And all constants need to be grouped together as like terms. Now, what some people like to do is they like to write the like terms next to each other. So 2y plus 2y plus 3, so that they can see their like terms are all grouped together so that they can easily add or subtract. And so now that we know which terms we can add, we can say 2y plus 2y, which gives us 4y plus our constant 3. I can't add anything to the 3 because it's got no other like term to it. It's just 3 by itself. And so it just stays plus 3. So guys, when we start to add more variables, when we start to add constants, it's so important that we are able to identify our terms and identify our like terms. All right, so what I'm going to do is just make that a touch smaller, and I want you to try question B for me. If anyone has any questions, you can raise your hand, or remember, you're welcome to put it in the chat. But have a try of question B for me. And remember, you're welcome to put your answers on the chat for us so that we can see. Ow. Mahal, do you have a question for us?
I'm going to give you the answer real quick.
Sorry, say that again for me.
I'm going to give you an answer. I'm still doing it up.
Okay, it's fine. You can leave your hand up. I'll call on you now to give us an answer. Okay, so guys, remember, find your like terms. If you want to group them together and write them together, that's absolutely fine. But remember, like terms must have the same variable and exponent. Right now, we just need to focus on the same variable. I'm not seeing any answers in the chat yet. Beatrice, if you have a question, you're welcome to raise your hand. Beatrice, what's your question?
Oh, Miss, I still don't understand by the constant. I'm still not getting the concept, or I'm not getting it.
So constant is just, it's not the same as 2y. So it can't be grouped with it as a like term. So it's a completely separate group of terms. So that's why it stays separate. If this had been 3y, then all of these would be like terms and I could add them together. But because it doesn't have a y, it's a completely separate group of terms that I'm dealing with.
Okay.
Okay, so that's why the 3 just stays the 3, because I can't add it to the 4y because it doesn't have a y.
Okay.
So that's all a constant is. It's a number by itself.
Okay. Thank you.
Sure. Right, Mohau, do you want to help us with B here? Do you want to give us an answer?
Answer is 9x. 9x plus 2. Yeah.
Alrighty. So let's group our
Cause-
like.
Wait, ma'am, can I say how I got it?
Okay.
I said 5x plus 3x. Then I put the 1 on the rx, and then give me 9x. Then I said 2 minus 4. Then it gave me 9x plus 2.
Okay. So guys, what I want you to be careful of here is the signs. Some of you are forgetting your signs. So if we group our terms, we've got 5x plus that 1x, like Mahal said, we've got a 1 in front there, minus 3x. Then our constants is plus 4 minus 2. So if we consider all of our x terms, and let's just go to a number line here. Oh, that's a 1, 2, 3, 4, 5, 6. Okay, so I'm starting at 5 x's. I'm adding 1x, so that takes me to 6x, but I'm then subtracting 3. 1, 2, 3. So that takes me to 3x. And then when I go and have a look at my constant terms, so the numbers by themselves, I've got 4 plus 2. So I'm starting at 4, sorry, not 4 plus 2, 4 minus 2, apologies. So I'm starting at 4 and I'm subtracting 2, leaving me with a positive 2. So when we simplify, guys, you need to take note of those signs. They're not just there for looks. They actually mean something. And so here our simplified answer is 3x plus 2. Right, so make sure you've corrected yourself. If you don't understand why it's 3x plus 2, please make sure you ask. I'm hoping that with the number line, that does make it a bit clearer. Lixa?
Sorry, ma'am, could I please ask how did you simplify the answer?
I've just explained it. Dal?
Man, but like, how did you get minus my fault positive 2 if it's like 4 positive 4 minus 2? Or is
Okay,
like
so
isn't that 2 like negative?
it is. So what it's saying is that I'm starting with 4, I don't know, whatever's, but then I'm taking away 2 of them. So I'm only left with 2. So yes, it's a negative 2. And that's why on our number line, we move to the left to the negative.
Oh, okay. Thank you, ma'am.
Okay, so guys, what sometimes is a bit confusing is that this negative sign, let's put the color here. This is saying that both the 2 is minus, or the 2 is negative rather. So the 2 is negative. That's what it's telling us. But it is also telling us the operation. It is also saying to minus 2 from 4. So that negative sign has a dual function. It's telling us that the 2 is negative, but it's also telling us that we must subtract 2 from 4. Right, so just be careful with that sign. It's telling us to subtract. Alrighty, so I'll let you take a screenshot. But here's question C that I want you to try. So I'll leave B up. That also might help you for C, but have a look at C and give that one a go and put your answers in the chat. And guys, remember, take careful notice of what signs you are working with. Okay, so just to help you out a little bit here, if we group, whoopsie daisies, if we group our like terms for ourselves, we've got a 6W, a negative 2W, and a positive 1W. Those are all my W terms. But then I also have constant terms, which are then the -1 and the +3. So take careful note of what signs it is that you are working with here. Okay, good. And remember, answers on the chat. Like what I see so far, keep them coming. Good notice or good attention to what signs we're working with. And grade 8s, remember, these lessons are recorded and the recordings go online. So if you've missed stuff that I've gone over, you need to just go and watch the recording. Okay, I'm going to give you another minute. Again, take careful note of those signs that you're working with. Right, anyone want to raise a hand to tell me how they did this? Right, Mialeni, do you want to help me out here?
So, ma'am, I did 6W plus 2W plus W, but I put the 1 in front of the W. So I got 5W. So 6 minus 2 equals 4, and then plus 1 is 5. So afterwards, 5W plus 2.
Perfect. So guys, exactly as was explained there, 6W minus 2W is 4W, plus another W takes us back up to 5W. And then we've got positive 3 minus 1. So if we're on our number line again, I'm just going to scroll up here. If we're on our number line, we're at positive 3, we subtract 1, so I'm left with a positive 2. Alrighty, so again, take careful notes of your signs. If your signs, or you mix up your signs, that's often where we go wrong, is we choose the wrong sign. So be careful when simplifying to have your signs correct. So what I'm going to do is you can screenshot all of them just in case you didn't get all of them.